The moon. Though we have set foot on it a few decades ago, it still drives the curiosity of many of us. Voices are rising, saying that in the future we might use the moon to mine resources and even set up permanent habitats. Also driven by their curiosity for the moon are student teams from universities all over Europe. These teams meet each other in an international space convention called Igluna, in the city of Lucerne, Switzerland. The students work on so-called space habitats, which prepare us for a future where we can become more self-reliant on the moon.
The goal of Igluna is to stimulate the technologies that students are developing, and these are fresh bottom-up ideas. So whatever the students want to build, we include them in Igluna if it fits the general Igluna topic. So it's about living on the moon, enabling life there for the long-term human presence on the moon. And with this, we hope to see the student technologies reaching the moon in the next couple of years. Also, we train the students so they become space experts, so they will be the next generation of space experts.
To get a better idea of what the student teams are doing, we asked some of them to explain their projects.
So the goal of our project basically is to marry the two concepts of lunar exploration with a rover and also solar sintering. Here you can see the currently closed lens that we use to focus the sunlight onto one tiny spot, and with that we can get a high energy density, so we can actually melt lunar sand. For long time space exploration, we kind of want to establish a base on the moon. And one great way to do that is to use resources that are already there. Our aim is to build structures by melting the sand, and we'll start with baby steps, right? Just create small patches on the ground, melt those into structures, and then continue on to larger structures, and then also layer by layer printing 3D structures. Yeah, so basically one interesting aspect would be landing platforms for other spacecraft, but also of course lunar habitats, so building the outer protective layer for habitats on the moon.
So we are the Robot Help Association. We are from Lausanne EPFL, and we are mainly growing and harvesting vegetables to provide food for the astronauts. So as we cannot use soil on the moon, we are doing aeroponics. So it's basically a pumping system that sprays water on the roots every minute. We have also put the LEDs to fake the light, and so this system is 100% autonomous and automated, so that the astronaut can go on missions, and when he comes back he has his vegetables ready.
These were just 2 of 12 teams participating in Igluna. Another team, Lunar Zebro, offered us to follow them around to see what it's like working in such a student team.
My name is Saji Makinwa. I'm an electronics engineer at Lunar Zebro, and today we're in Lucerne, and for the upcoming weeks we're going to be partaking in the Igluna event.
Yeah, it would be awesome when there's like a piece of electronics designed by me and together with others, of course, which is like walking on the moon in a few years. That would be amazing.
In our case, it's going to be a rover, which is going to be walking into a docking station, charging, and hopefully exploring the terrain.
So, Lunar Zebro wants to put small rovers on the moon. These rovers are easy and cheap to manufacture, which is unique. The team wants to put a swarm of these on the moon to explore more dangerous locations and perform new kinds of missions.
Lunar Zebro brings a lot of swarming rovers here to the test bed, and they should interact autonomously, which is a definite challenge, and a challenge we should tackle for future lunar missions. And I think this communication, but also getting each of the systems running reliably, that's the biggest challenges for them, and I'm glad that we can provide the setting to test this.
The student team will test a couple of these rovers on the Mount Pilatus in Lucerne.
We help Manuel to set up the fence and everything else. Once we are done, then we all together go by cable car to Pilatus and then release them.
For lunch.
For lunch.
We're going, so we're like almost halfway through the mountain where our test bed will be, so where we will install the docking stations and where the rovers will be operating. Yeah, I think today we're going to kind of fence the space that we will be using, so kind of determine that. And also just generally we'll go there to kind of have some sort of mapping of the space and realize what challenges we would be facing. So yeah, I'm really curious.
So we need to set up your test bed, which is mow the lawn. That was one of your requirements, of course. We tried to ask the farmer, but he's only going to mow the lawn right after we finish. And
I also brought a tent. So today our first day visiting the test bed. This is our test bed. You can see that it has been already fenced, and we are using some police tape to make the fence. You see the wooden pegs that are there, and then the police tape is used to actually mark the fence so that rovers can detect the fence. If you can put the axe,
Wait, what? Oh, yeah.
Wait, that's perfect. Wait.
Pull it a bit more towards you. My shoes are fully soaked now.
Let's get into the technicalities. How does the rover actually work? And why do they need to test it so high up on a mountain?
Because you're basically now going to be communicating to a quite far place, far away from Delft, and trying to relay information which is sent from the rover back to Delft. And if you can do it on a mountain, it might give you some more confidence that you can also do it on the moon.
Lunar Zebro's project consists of multiple rovers and docking stations where the rovers can recharge.
Yeah, basically the rover just comes to the docking station and it can send a message like, okay, I would want to charge. And then, for example, the PCB can then measure the distance to the rover, and it can also ping the signal via the charging coil, so that it exactly knows when there's a rover on the charging coil, so that it could charge.
There's a lot of work to be done if the team wants their rovers working in the end. They need to stay up late working in their apartments.
Like if the IC is the problem, then we just shift it to another one. Can you try it? But if,
yeah, because you're saying that PCB is most likely not. At 11 o'clock, when we know how much progress has been made, we can update Krishna and Justin for people who can solder for you. Things that will be picked up, I can drive back and just pick up stuff. Yeah? Okay. Then what else is left?
Now able to also control the Raspberry. So we left the Raspberry for the docking station, we left it there. So we can now also connect to the testbed from here via SSH. So we can now continue doing this even when we're home and not necessarily on the mountain.
Tomorrow is to make one rover walk on the test bed as soon as possible, and that's it. Every other activity that has to be on the test bed, like docking station, can pause for now. Okay, that's done. Who is cooking tomorrow?
Lol, that's it. You guys are mean.
He is sitting there as some kind of slave.
Give you no confidence.
Swarming capability of Lunar Zebro is a challenging aspect because it's new. It hasn't been done before, at least not on extraterrestrial bodies. We have had lunar missions, we have had Martian missions with single rovers, but never with swarming rovers. And that's, I think, the challenge that the team tries to tackle. And I believe they're on a good track to, in the coming years, elaborate on that and be a success.
The moment of truth is coming up, displaying the rovers on Mount Pilatus.
Tomorrow we aim, depending on the results of today, to have 2 walking rovers in the testbed, and that's the main thing, to show this locomotion principle for a longer time.
But almost no project is without failure. The team has run into some troubles letting the rovers walk around.
I must say that it has been quite difficult to cope with the drawbacks that we've had, because a simple mistake can destroy hours or days of work. And these mistakes have happened with both the rover and our docking station systems.
Yeah, so a motor burnt out essentially, and now the rotors cannot spin at all, and therefore the motor cannot spin at all, and they're effectively broken. We didn't really anticipate it happening. It never happened before in Delft, and now all of a sudden we are facing this issue. So we're trying to find out why it's occurring suddenly now.
And these mistakes happen, unfortunately, and these components have to be completely redone, which takes a long time and a lot of concentrated effort as well, because you don't want to repeat this mistake. It is not easy to stay motivated after you just saw an error occur and then say, okay, let's start all over again, work hours or days to fix this. So far the team has shown definitely discipline, motivation and a will to go on, so that's important.
Sowieso voor het nieuwere design, zeg maar, voor de aankomende jaren, dan moeten we wel wat systematischer te gang gaan. Ja. En meer eigenlijk op de minder interessante dingen ook gaan letten. Bijvoorbeeld, hoe veilig is de PCB? Wat gebeurt als je hem aansluit met hoge spanning of lage spanning?
Ja. Maar dit nemen we voor ons hele leven mee.
Ja,
dus deze herinnering blijft altijd in zitten.
Ja, want nu gaan we geen PCB meer maken zonder overcurrent protection,
under voltage
protection, et cetera, et cetera.
I can write 1,000 pages of a book for this, what we have learned in this campaign. The team always has to stick together no matter what it goes. A team will always win and lose as a team. And I think I'm proud to say that the team has learned this thing. So the main thing is, if you have a hinge, that things can go wrong. I think you should not overlook it. You should actually look into it and have a mitigation plan as soon as possible to make sure that even if it's less probable, it will happen at some point down the line.
Even though the project didn't go as they hoped, the team expressed that they had learned a lot from it. Will there be a sequel to this story?
Oh yes, definitely. There's going to be a sequence and then a sequel and a sequel to that, because we have to still go to the moon and we still have a lot of hurdles to pass over. So yeah, just keep looking out for more and more exciting work that we have stored in the next couple of years.